All right, so in this video, I want to determine if these polynomial functions are odd or even. I want to do it algebraically, not graphically. Remember, for our test, we always test for even first. And if f of x equals to f of negative x, then we know that the function is even. We always do this test first. Now, if this test fails, we test for odd. So if negative f of x equals to f of negative x, which is basically the solution here, then the function is going to be odd. And if the function is neither even or odd, it's just neither, basically. So if both these conditions fail, it's just going to be neither. Remember, we always test for even first. So let's try this first example over here. We have f of x, the original function. I want to find f of negative x. So I'm just going to replace every x with a bracket and a negative x. And now I want to simplify. So negative x to the power of 3 is just negative x cubed, because negative cubed stays negative and x cubed is just x cubed. So this is going to be negative 5x cubed. Negative x squared is actually positive x squared, because negative times negative is positive. So the sign stays the same over here. It doesn't flip. This stays as a negative 2x squared. Negative 2 times negative x is positive 2x, and the plus 6 stays the same. Let me compare this to the original. You can tell that these two are not the same, because this is over here positive, this is negative, this is negative, this is positive. So a couple of differences. So this function is definitely not even. Let's test to see whether it's odd. We already have f of negative x. Now I just have to find negative f of x. So negative f of x, to find this, you just put a negative sign, you open a bracket, then you write the original equation f of x inside the bracket. So 5x cubed minus 2x squared minus 2x plus 6. And then we just distribute the negative into the bracket. Plus 2x squared plus 2x minus 6. Make sure to distribute it to all your terms. Now we're going to compare these two. Never compare the original with this one. There's no point in doing that. I'm going to compare these two. And if these two are the same, it's going to be odd. The first term and the third term are the same, but again, the second term, the signs are the opposite. The last term, the signs are the opposite. So this is also not odd. This is going to be neither even or odd. Take a look at some more examples. Let's take a look at this second example over here. Again, I'm going to start with my test for even. So I'm going to find f of negative x. So I'm going to replace all my x's with a negative x. So negative to the power of 4 is positive, because any negative to a positive even exponent is always positive. So this is just going to become negative positive 0.5 x to the power of 4, because the negative is going to just disappear. It becomes negative to the power of 4 is just positive. Negative to the power of 2 is positive. So this one also, the negative just disappears. The sign stays the same. And then negative 6 is negative 6. If I compare this to the original, you'll notice they are exactly the same, which means that this is an even function. I don't even have to go to my test for odd. And let's do this last example over here. So f of negative x, I'm going to replace all my x's with a negative x. Now I'm simplifying it. So negative x to the power of 5 is negative x5. I'll actually write this out in an extra step to make things a bit easier for you, but you can normally skip this step. This is just negative x to the power of 5. The negative stays because negative to an odd exponent stays negative. Same thing here. This stays negative because negative to an odd exponent stays negative, and negative 4 times negative x is going to be positive 4x. Negative times negative is positive. I can multiply these brackets out now. Negative times negative is positive. So this is 3x5. Positive times negative is negative. So minus 2x cubed plus 4x. So if I compare this to this, we'll notice that all the terms are not the same. So it's definitely not even. Let's do a test for odd now. So negative f of x is just negative, and then I'm going to write the original function inside the bracket. Now I'll distribute this negative into the bracket. So I have 3x5 minus 2x cubed plus 4x. I compare these two, they are identical, which means that this function is odd.